Hello, ninth grade. This video is to review how to create a box plot and a histogram from data. So I am using 6th hour data because I'm creating this video before we get to create or measure data in class next week during our lesson on displays. So first thing you'll need to do is to write down the individual data. So you can see that I have written down all the 24 measurements of the student's hand span. Now I'm going to go to the graphing calculator and enter in the data, stat, edit, and you can see I have all of the data entered. The 24th piece of data is the maximum, and it's all in order. So now to find the 5-number summary, again, stat, but arrow to the right to calc, enter 4 times. 1, 2, 3, 4. And what we have is the mean, which is about 19.8, and then the standard deviation, which is 2.98, but the 5-number summary is 13.5, 17, 20, 22, and then the max, which is 24.5. To create the box plot, leave about 4 or 5 spaces below your 5 numbers. Draw a number line and create a consistent scale. Here we go. So I'm going to start at 13, and then I'm going to go up by 2 spaces. And I'm going to do my best to be consistent in how I create my marks on my line. And then I'm going to mark the minimum, which is just past 13. Notice that I am moving up into the spaces above the number line. Don't put it on the number line. It gets too messy. Create space between the box plot and where the numbers are. The maximum is close to 25. But now the median, which is 20, and the quartiles will be vertical lines that create a box. And that's why it's called a box plot. So 17 gets a line. 20 gets a line halfway between 19 and 21. And then 22, halfway between 21 and 23. Finish the lines of the box, and then extend from the end of the box to the minimum and the maximum. And so here is our minimum. Here's our first quartile. The median is that middle line, or the line that's in the box. And then the third quartile and your maximum. Now let's look at how spread out our data is. We have 25% of our data in between each member of the 5-number summary. Notice that the box is 50% of your data, but the first half of your data is 50%. And then you also have 50% at the end of the data from the median to the max. So we can say that this is an analysis statement. 50% of the students have hand spans between 17 and 22 centimeters. And if we look at the data, let's see if this is true. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 out of 24 students in this range, which is exactly 50%. Now, because this distribution, if we look at this picture, it is very what we call symmetrical. This means we have the same amount of data to the left of the median and to the right of the median. So please also add the word symmetric. Now we're going to create a frequency table. So I'm going to slide up my paper, but I want to make sure I can see the raw data. Frequency table. What we're going to look at are intervals. We have between intervals and frequency. Number of students. So our intervals are going to be between 13 and 15, but not including 15. Then 15 to 17, up to 17. And then 17 to 19, 17 to 19. And then 19 to 21. 21 to 23, and then the last one, 23 to 25. Those are all centimeters. Now, there is one student in the 13 to 15 centimeters range. There are 3 students between 15 and 17, not including 17. So these 3 students all had 16 centimeters. 17 to 19, there's 4 students. 19 to 21, 1, 2, 3, 4, 5, 6, 7 students. And then from 21 to 23, there's 4. And then 23 to 25, we see 1, 2, 3, 4, and 5. Now quickly looking back to make sure, let's make sure we've included all 24 students. Here's 9, plus 7 is 16, plus 4 is 20, plus these 4 is 24 total students. Now we will create our histogram. First, draw the L. All of our frequencies are positive and our intervals are positive. So we'll use the positive x-axis and the positive y-axis. Please create a break right here because our data does not start until 13. And then go up by 2s, just like the frequency table. Make sure to label this axis. Hand span centimeters. On the left side, these represent the number of students. And the title of our graph will be 6th hour hand spans. Now we're going to create the bars that will be the exact same as our frequencies. So I'm going to number the y-axis going up by 2s. 2, 4, 6, 8. Notice there's 2 spaces or 2 students between each increment, so I don't need a break vertically. But again, because my data did not start until 13, there's a break here. Otherwise, my next interval should be 26, and then 39, and then 52, 65, going up by 13. But I'm going up by 2s consistently after the break. Okay, I'm going to zoom in on this histogram. So between 13 and 15 centimeters, we only have 1 student. So the bin is going to go up to the middle of this line. 3 students are between 15 and 17. Then we have 4 students between 17 and 19. 7 students. This is our modal class, the interval that has the most students. And then we go back down. 4 students in this range and 5 students in that final group. And from this picture, you could kind of say that it's skewed left a little bit because there's less over here. But it's also fairly symmetric around this interval. So consider what you think and make sure that you can explain why. Excuse me. Take a look at how histograms are different from bar graphs. Remember, all of these bins are connected. There's no gaps. And here we have number ranges. That's why it was important for us to have a break. And here's where we can see the shape of these histograms. Notice we're a little bit like this one where the left side is stretched. So there's less data on the left side, so we have a negative skew. But it's also pretty symmetric around the modal class, which is 19 to 21. And if you would like to note that in your table, you can. It is the class or the modal interval with the most students. Thank you for watching this video.